The first time that a barcode was used was in 1974 in Marshupper Market in Ohio. Since then, the act of scan and a product in a machine has been repeated billions and billions of times around the world. The vast majority of commercial products are equipped with the UPC labels. We can say that the Universal Product Code was one of the first developed OCRs, although characters at that moment had to be simplified as much as possible, only white and black stripes. Today, 46 years later, it's still as valid as the first day. In general, in ports, we do not use barcodes, but we use OCRs in many things. As an example, we use as a part of our operations in the field of recognition of vehicles or containers, and that has facilitated the development of automatic gates in our ports. In effect, if we use OCR and digital communication with truck drivers, we can access the port and its terminals under a paperless basis. That means that the system uses cameras to identify the truck, compares it with the PIN code entered by the truck driver, and if everything is correct, the system allows the entry of the truck. If we introduce a little intelligence to this process, we will be able to develop predictive models about what will happen in the doors of the terminals and make some decisions about that. That means that we are creating what now we call virtual gates. Some ports, like the Port of Barcelona, is implementing this kind of systems. But we are not talking just about truck identification. Today, image recognition means something like security, biometrics, facial recognition, items counting, non-intrusive scanners, etc., etc., etc. If we combine the development of artificial intelligence and machine learning with image recognition and artificial vision, possibilities multiply. Indeed, the ability of current systems to interpret and recognize images and to learn from them allows us to move towards high decision models and, in the future, to automatize the decision processes. Now, we would like to present you 3 initiatives in which the Port of Barcelona is working together with various startups, linked to the use of artificial intelligence and machine learning to the artificial vision and image recognition that will give us a glimpse about the possibilities we have in this regard.
We're Allread Machine Learning Technologies. We're a deep tech computer vision startup that developed a software that extracts text, codes, and symbols in operational environments, even in the most complex and challenging operations. Based on that technology, which is the result of 5 years of investigation in the Computer Vision Center of Catalonia, we have started to work with the Port of Barcelona. Actually, the Port of Barcelona was our first promoter, let's say, the first one believing in Allread Machine Learning Technologies, and where we started to track their assets in the port infrastructure. We noticed that despite existing technologies, optical character recognition, that do track containers, license plates, dangerous goods signs, wagons, all the assets coming in and out. There are 3 million containers going in and out every year in the Port of Barcelona. Well, there's still a lot of limitation of this OCR technology. It's capital intensive, it's rigid, it creates bottlenecks, and it still makes errors. People say, or most studies say, and our interlocutor and our spokespersons say, that there are between 3 and 5% of mistakes in the reading process of traditional OCR. So our goal with the Port of Barcelona, and on request of the Chief of Operations of the Port of Barcelona, is to develop a solution that disrupts the OCR like we know it today. An agile solution that's able to be plug and played anywhere in the port, starting with the train transport, which is the less automated, where the tracking is less automated. For instance, in Spain, there is no tracking solution for trains in the ports. So what we're developing with the Port of Barcelona since a few months now, and what we're going to go on developing with them, is a solution that can track simultaneously containers and wagons without the usual cost-expensive hardware infrastructure, no sensors, no lasers, no 6 cameras, no gate. We're just going to put a few random CCTV cameras and extract all the relevant information to be instantly digitized and sent into the information management system. This way it's going to be there'll be a higher return on investment. Actually, it has also a positive impact on the sustainability, because there are less bottlenecks, less trucks. If we promote the train transport, which is less polluting than the road transport, and basically a better service for the clients of the Port of Barcelona, and we hope all the ports in Spain. So this is what we do. This is Allread Machine Learning Technologies. Don't hesitate to contact me.
Together, Deloni and Deep Solutions, we have developed a solution that allows you to optimize a cruise terminal in terms of its mobility. We call it Smart Mobility Analytics, and we have reached to one KPI that we think is very important, which is the transit time of a passenger through the terminal. In fact, imagine that when you book a cruise ticket, what you're aiming for is a pleasurable experience, and also you want to have no worries, and if possible, not too much waiting, right? That's what we're trying to solve, and it's actually traceable. We can know the time of waiting of every passenger from the time they exit the boat to the time they leave the area. And basically imagine that you are in a ship and you decide to take a taxi. You want to go do some sightseeing. And how do you optimize the taxi area? What you need to do is you need to know the amount of people, the amount of taxis, and according to that, you know if you need to call more taxis, right? Also, imagine that you want to take the public bus. The manager of that area needs to understand how many people are going to want to go in a bus, so they can schedule a specific frequency of buses coming in and out. Also, imagine that you want to take an organized trip and you go to a bus organized by the cruise ship, for example. Is there enough space for all the buses in that terminal? Or if somebody picks you up, in fact, is your friend going to be able to park or not? These are all the questions that we help answer. We are using, of course, deep learning. We're using convolutional neural networks that allows you to completely automate all the process. And we are doing from detection and recognition of plates, recognition of faces in some occasions, and we also track the movement of people and vehicles in the area. This all amounts to a real-time flow of information that can be used by the manager of the area, in that case, to make decisions as the situation changes, which sometimes is not completely predictable. Depending on the origin of the boat, country of origin normally, type of boat, and more importantly, the total amount of people in the boat. With our tool, you can analyze and also predict what's going to happen in the future in boats that you've never seen before. You have a database of knowledge that you can use to your advantage and for allocating resources that you might need, such as a frequency of public buses, taxis, and all these things. And so on top of that, there's an understanding that once you know the needs of every single boat, then you can redesign terminals that pretty much optimize every single area and are tailored to the boats that you choose. And so, well, in general, our solution aims to improving the optimization of the transit of people through a cruise terminal. Thank you very much.
Hi, I'm Jorge. I'm CEO of 3D Modeling Studio, and we created Clever Volume. Clever Volume is a simple and automatic and scalable solution for measuring and classified waste, solid waste. Basically, Clever Volume is a two-step solution. It's a remote sensing-based kit. It's a one-time configuration kit on site that allows us to create a digital twin of our waste. And then we have a remote software. It's a cloud-hosted software that is working in real time, continuously creating outputs adapted to the end-user devices. Well, Clever Volume allows ports to first estimate and keep track and fill invoices of waste, the waste operation, and especially the waste discharged from ships. So it's a MARPOL Annex 5. Clever Volume means also clever ports because we operate 24 hours, 7 days a week, independently the environmental conditions. We can implement a continuous, a never-ending flow of waste operations, and we save human resources, and especially the human resources in positions with health risk. And fundamentally, Clever Volume allows or empower port with the capacity to comply with the new regulations. Regulations in terms of interoperability, in terms of waste unit of measure, and especially in this transition to the digital era. And there is one goal I want to mention too, and Clever Volume contribute to the reduction of ocean pollutions. Basically, if we implement or if we empower the port reception facility with Clever Volume, we will be able to close the loop in the life cycle of the waste, and we can move toward the circular economy, and we will bring more waste to the shore, discharged onshore. After getting awarded by the Smart Catalonia Challenge in 2019 and getting the Seal of Excellence of the European Union, we implemented the Clever Volume solution as a project pilot in the Port of Barcelona. The relation with the Port of Barcelona has been far, far, far beyond a mere facilitation. It has been more a co-creation relationship. We believe and we implement the development based on user-driven innovation, and this has been a reality with Clever Volume. I am convinced that the success we have achieved so far, and especially how well we can or how efficiently we can answer specific needs in a way that Clever is doing now, is basically because the strong collaboration we have with the Port of Barcelona along the last year.
We can imagine a port where, thanks to the information from the cameras, advanced 5G communications, and the use of artificial intelligence, you can control the ships by remote systems. You can imagine a port where the use of real-time traffic management systems, vehicle flows are managed autonomously from information provided by multiple cameras, and transport routes are optimized. We can imagine a port where artificial intelligence is able to detect collisions and to avoid it before accidents occur. We can imagine a port where leaks and spills are detected by cameras. All these ports, and many more, are possible, and they are very close.